I made it. I'm like 15 minutes late, but I really was debating if I was about to watch class live. Um, I'm a few minutes behind, but I still want to watch now because if I don't, I feel like I might get further behind. So that being said, I already prepped all this stuff. I just need to share my screen. Okay. I have a meeting at 3, and my watch is dying again. Yay! Hold on, let me plug my watch up, and then we can start this. I should have never went and got something to drink, but I think he will accept his nap. I need to get into the zone. Okay. I have a meeting at 3. Yeah, 3. So I should have enough time to finish. I just need to lock in on this. Actually, I do want to take notes though. I didn't take notes last time, but I saved myself a couple pages because this is definitely some information that I need to be keeping track of. This is not the only like agentic stuff I'm doing, but I guess I got like a lot of notebooks since I'm going to be starting school soon anyway, and I have been studying. So this is going to be session 2. Oh boy, I just need to focus. I think I have enough time to finish this though. Yeah, I should have enough time to finish. So I wonder, can you change the playback speed? Can I like put it on 175 to catch up? Really curious how that goes. I never tried to change the playback speed in on a live event, so let's see. It might work. Then hopefully once I get to the live part, it'll just go back to normal speed. Okay. What am I trying to do? All right, we don't need our music right now. My watch is on a charger, so I'm gonna try to keep up. So loud.
Hello, everyone. Good morning, maybe good afternoon or good evening from wherever you're joining us today. We do have folks from 50 plus countries who are joining us. So again, wherever you are joining in from, welcome. We're super excited that you're here. My name is Erin. I'm a startups program manager at Google Cloud. I'm really excited to be here today as a host of the session. All of you should know, but I'll just give a quick reminder. Today's session is Architecting Intelligent Agents. So we have 2 fabulous speakers that I'm excited to welcome back to the stage, to the Startup School stage again, Abraham and Luis, who I will introduce shortly. They will talk about some of the essential blueprints for creating scalable, secure, and powerful agents. And they're also going to dive deep into some of the components of cognitive architecture today. So again, we're really glad you're here. It's going to be a great session. All right, before I introduce today's speakers, I'm just going to run through a few minutes of housekeeping items, some reminders. I know we always have some new folks, and sometimes a refresh is helpful. So bear with me before we get to the good stuff. So as a reminder of where we are in the curriculum, first and foremost, if for some reason you haven't heard, we do have a week 0 session available. This is all about building your first agent on Google Cloud. So it really is all the aggregated, essential kind of starter sessions and components for startups and developers. So if you haven't checked that out, go take a look. It's on our main landing page if it might be helpful for you. All right, so we are in week 1. As you all probably know, we had an amazing first session with John on Tuesday. And today, as I mentioned, we have Luis and Abraham who will be delivering today's talk, which is great. Next week, we have week 2 coming up. So you'll learn more about the agent engine and its overall potential. In week 3, we will deep dive into building and deploying your first agent. And we also are really excited to share that Datadog is joining us as our program partner. So their session will cover LLM applications and how you can use those with Datadog. So we've got a great curriculum for you guys. And again, we're so excited that you're joining us. All right, a couple more reminders.
It's on 2x speed or 175 right now.
For anyone who's new to Startup School, and we host
because
live
I'm
sessions
behind.
each Tuesday and
I'm trying to
Thursday
catch up to live.
Following the live sessions, all of the sessions are available on demand. So you can go to our landing page, you can take your time, rewatch just a section of the talk, right? If you need a refresh. All of the sessions are available on demand after the live session wraps. So if in an hour or so, the session isn't available, refresh the landing page. They should all be there. Other component is our Skills Boost labs and notebooks. So we provide recommended labs for you to go and do hands-on learning yourself after the live sessions, after hearing from our experts. And the Skills Boost lab, we want to give you access to try all the technologies and solutions we're discussing for free. The labs allow you to practice with guidance. We provide a link with the full list of labs for you to check out that we do recommend. I'll go into more detail on this in the next slide. And then just something else fun to note, you can earn some skills badges when you complete some of the labs. So, for the competitive folks out there, getting badges is always fun. All right, let's talk about Cloud Skills Boost quickly. So to be able to access the labs that we're recommending free of charge, you do need to fuel your account with credits on the platform. So all of the information you see on this slide was provided in reminder emails.
I'm just speeding through the intro stuff.
You please double check your spam or junk folder.
Because I have to finish by 3.
Nearly 100% of the time, the emails are there. They're just hard to find. But we're going to cover that really quickly. So scan the QR code that you see on your screen or use the link. We have full instructions via the QR code or the link. So you'll scan that to redeem your credits. Fill in your details. You're going to have to do an email verification and then This is the most important step, and what everyone misses, you have to finish the intro lab, which is a tour of Google Cloud hands-on labs, and you do need to spend a minimum of 6 minutes on it. And once that's done, the credits are then added to your account. If you have any questions or you have any issues, you can email startupschool-external@google.com. If you need help, our team is here to help you. All right, and last but not least, in terms of housekeeping. So these should help you make the most of your time at Startup School. So as you can see on your screen now, there's a chat function on the right-hand side, and then below the live screen, there's a Q&A panel at the bottom. So we have amazing Google AI experts on hand. They're there to answer any questions that come up for you throughout the class. So please ask your questions in either of those spaces. We do save around the last 10 minutes of class for live Q&A with our instructors. We will select the most commonly asked questions and those relating directly to the content covered today. So you can upvote questions in the Q&A panel and then use the chat space to converse with other attendees and participants. Mentioned this before, but just to reiterate, we're recording each class. You'll be able to watch all the sessions back on demand at a later stage, and you can access the recordings via the main program page. We also do send weekly recap emails linking to all those sessions on demand, so several places for you to find everything you need. As a reminder, we do not share slides, but we will share the links to the labs covered in class, both during the class in the chat space as well as the Q&A panel, and then we will include that link as well in our weekly recap emails. If neither of those things work for you, you can also find the list on our resources tab on our main landing page. Last but not least, always helpful to remind the group that this is a hands-on training series. Most classes do cover a lab or demo. All of these are available on the Cloud Skills Boost platform or on our Google Cloud GitHub repository. We share all the links with you to access both of these things. So we really strongly recommend using the time during class to listen and watch our instructors going through the lab and completing it after the session. The credits that we provide do last you for the full 3 weeks of the program, so you have plenty of time to do them on your own. All right, that is it from me. I'm so excited to invite today's speakers to our virtual stage to lead class. So Abraham and Luis, welcome back to the Startup School stage. I'll see everyone a little later for the Q&A section. Enjoy class.
Thanks so much. How's it going, Luis?
I am well. How are you today?
I'm gonna keep it on 125 right
I feel
now.
I have the best seat in the house because I'm pretty much here to learn. Just
if I keep it on 125, it sounds. Wait, let me listen to them.
Tell the audiences. So, if you don't mind, pop up the slides and we could kick this off.
Yep.
Okay, 125 sounds comfortable, but also I might possibly catch up. I'm like how many minutes behind am I? I'm like 20 minutes behind right now. I might not catch up at all.
So today, architecting
I have to finish by 3 though.
And building a foundation for success. My name is Abraham Gomez, and I'm here with one of my favorite Googlers, Luis. Like I said, my goal is to be that conduit for the folks asking questions. So I am looking at the chat. Luis is going to help basically guide a lot of the demos. So I'm going to try to, ask him a few questions just to make sure that we have as much clarity. And again, for everyone that's out there, right, like this, all the work that Luis and I and everyone else put is for you guys, right? So please ask questions. We're here to, push this whole presentation to benefit you guys. So let's talk about what we're going to be talking about today. So first, we're going to talk about LLM 101, basically what are LLMs? Then we're going to talk about sort of the transition that we've seen from 2023 to now with these base models and how they sort of became agentic. Luis is then going to pause, do a demo, then we're going to come back and sort of talk about what is an agent. Then we're going to do another demo of more of a take that's more focused on agentic AI versus just base models. And lastly, we're going to finish off on 2 points on just how to use agents on Google Cloud, what are the tools and services and products that you can leverage, and also things on the communication and security. Sort of hot topics that you may have heard, MCP or agent to agent, but if you haven't, it's perfectly fine. We're going to talk about that later. So let's jump onto the next slide. As you guys know, right, there are a lot of models out there, right? Compared to what was available in 2022, now there's an abundance of models, right? Just on Google side, right, you have many flavors of Gemini, but then on the media model side, you have VO, right, for video, images or Imagen for images. You have Lyra as well, right, for audio, and then you even have music. So there's a lot of these models, but I think sometimes it's helpful for us to sort of, one, take a deep breath, not get overwhelmed that there's so many options out there, and sort of ask ourselves, like, what are these models really doing? What are they? So let's talk a little bit about what is really an LLM. I think in 2023, 2022, many folks were asking themselves, is it a neural network? Is it a transformer, right? Is it sort of a fancy autocomplete or a snapshot of the internet? Is it conscious? Is it magic? I think the best sort of definition is actually something that Andrej Karpathy said, actually very recently in around January, February of this year, right? He said it's a token level internet document simulator. Say that 3 times. Essentially, right, what Andrej is trying to say with this is that what early base models were doing is they're getting all of the internet, right? And you're trying to compress this into a way that, one, makes sense financially, but also is efficient to run. And this sort of process of getting the whole internet, right, and creating it into sort of a more consumable method is, we use tokenization, right? There's other algorithms, but essentially you're compressing this. And if you go to the next slide, Luis, we have sort of a way that sort of illustrates this, right?
And really quickly, internet, right? And I want to be in picture-in-picture mode, actually. Hold on, let me, so messed up. I'm about to close every single one of these windows that's open. Bye. I'll see y'all later. I can always reopen y'all, but that's too much distraction for me right now. I don't even recognize myself because I never close tabs. That's crazy. All right, I want to be in picture though, because if I go into picture in picture, where is it? I have more control over using my browser at the same time. Let's see. I don't want to go back all
Putting
the
it
way.
into sort of a more consumable method is we use tokenization, right? There's other algorithms, but essentially you're compressing this. And if you go to the next slide, Luis, we have sort of a way that sort of illustrates this, right? I think what's really important to know is that base models, right? They see the world in tokens. You and I, right? We may see the word, for example, lazy, like that's on the screen. We see 4 characters, right? We see, and we define that as one word. But for a base model, right, they see that as a token. Now that could be a random number that's just one token. It could be 2 tokens. It depends on the context. But what they say with the token is sort of that context awareness. So as these base models digest the world around them in tokens, right, their number one job is to predict the next sequence. So a few examples that we have here, right? Jack and Jill went up the blank, right? The job of the LLM in this case is to fill in that blank, which all, intuitively we all know that it should be hill. Jack and Jill went up the hill. It would be weird if it said Jack and Jill went up the I love chicken noodle soup, right? That doesn't really make sense. Statistically, that's not what you would think would be the likely next completion. And I think that's also a really key part is that in academia and in research, right, the output of an LLM is what we call completion. In development world, right, sometimes it's called response, which is completely fair, but I think it helps us to understand that by completion, right, we mean that it is completing the next, order of operation. In this case, when it's text, it's going to be text, but when it's images, it does the same sort of thing in the back end. So let's pivot real quick to sort of talking about now, this was sort of what base models were, let's say 2020 to 2022. As 2023 popped up, right, there was now a demand from the market of, hey, we want our base models not only to complete and provide this autocomplete method, but we want them to also provide access to external tools, right? And this is sort of where the model training began for the reinforcement training of the model is, hey, we want to teach the models not just to autocomplete, but also that functionality to call a function, right? We call this function calling, and it is really crucial tool, right, in the core of agents. Imagine if you try to build an agent right now and you cannot access Google Drive and you cannot access Google Maps or Gmail or anything like that. It's very difficult to sort of expand the opportunity that your AI applications can have if they don't have this very key portion. Luis, before we sort of jump into the demo, I'm curious, is there anything else that you would want to add?
Yeah, I think the key thing here is, this is an abbreviated version of a set of a presentation that we did for the startup school in Q1. So if you want to dive deeper into some of these topics, please visit that, and we will provide links to those recordings. The other thing is that since this is abbreviated, we're not really diving deep into what reinforcement learning is and all the effort that goes into generating any kind of a model, whether it's a large language model or an image generation model or any other media generation model and so forth. Our focus in this session is going to be agents, and so we have we're going to try to avoid distractions by talking about other things related to models. So that's it. That's all I wanted to add.
No, perfect. And yeah, the tokens, regardless of the modality, right? If it's image, video, and text, right? The key thing to know is that the base model is trained to predict the next statistical likelihood thing that would follow, right? And I think that's the key part to remember, because as you're developing these agents, right, just know that that's sort of the inherent way that these base models want to behave. So you want to take advantage of that, and you want to sort of nurture them and sort of make it easy for them to complete, right? Because we all had that experience where you talk with like a model and it just doesn't respond the way that you were hoping for.
Yeah.
Sometimes it means you didn't give it enough context. Sometimes that means there was a slight hallucination, right? Or maybe a plethora of other issues that we call sort of prompt engineering. So let's go to the next slide, and maybe you could quickly talk about what you're going to demo, and then let's just jump into the demo.
And I'll leave the slide up a little bit longer. And I was monitoring the chat, and I saw some people seem to have recognized me. And they were already kind of assuming that I was going to show off this notebook. But first, follow this link, and you will see links to other Colab notebooks out there that that we'll be using for today's demo, particularly notebook number 2. And I'll show you this in a moment. So I'm just going to leave it on the screen here. And so the goal here is, once again, we're going to focus on agents today. So let's go ahead and jump over to the next to the actual notebook that you're going to be seeing initially. So this is the Luis Lab notebook, named after me because, well, that's just the way somebody named it. Actually, it wasn't my fault. But anyway, so yes, so you're going to see here links to two notebooks. One is an intro to Gemini development. Let's ignore that one for now. We're not going to be using that one today. We're going to be using the Agentic Gemini basics. So when you go ahead and click on that particular link, you will be sent to this other notebook here. And this notebook is the one that we will be following today. I'm going to be using a blank notebook so that we can avoid some distractions, my friends. So, but nonetheless, you'll see here that we're going to go step by step through the process of setting up our SDK and client. We're going to invoke the model. We will explore function calling. We will then start developing some basic agents. And then if there's time, we might do some bonus exercises. So that's the long and short of it. So let's go ahead and now switch over to my final Colab notebook, which is the one that we're going to be using for the rest of today's presentation. And very briefly, I'm also going to put the link to the lab in the chat. I just did that, so go ahead and follow that at your convenience. All right, so so what you're seeing here is this fairly blank notebook. All I've done in advance is that I've installed certain libraries into my my Colab environment here, and we're going to authenticate. In this case, I'm personally authenticating to Google Cloud, and the way I'm going to run it is through Google Cloud. But I should point out that we do support Google AI Studio. So if you want to use that, all you need to do is go into the secrets management section of the screen and add a variable called AI Studio API key, which is the same thing you see here on the right-hand side. And once you do that and enable that particular secret to be exposed to the notebook, you can use AI Studio for this exercise. Okay, so this exercise does not require a Google Cloud account, although of course I highly recommend that you do create one at some point and develop some experience with that. So let's go ahead and go ahead
before you start. I know some folks, sometimes the QR code doesn't work or anything like that. The moderators are adding the links in the chat.
Yes.
So just make sure. And then also one thing, sometimes it does get distracting. I know running code as you're listening. So just be aware that this is going to be recorded. It's going to be sent out later. And all the links, right, we're going to make sure that you guys do have access to them. And again, the moderators are adding the links directly.
Yeah, and I guess a big point here is I suggest you not try to follow along. Don't try to execute the cells. Certainly if you want to, by all means, but instead I think pay attention, right? Like look at what I'm doing, try to understand the big picture, and then at your leisure, you can go through the lab exercises step by step, very calmly on your own time. And yeah, that's the long and short of it. We're going to talk about this later, but there is a Discord channel, and I do participate in that Discord channel, so you can hit me up there if you have any questions in the future, okay? So, and you will get links to that Discord channel a little bit later as well. So let's go ahead and just kind of proceed here. So, so what I'm doing here is authenticating. First off, I've already authenticated to Google Cloud in advance, and in this particular case, I'm going to initialize my generative AI client with my GCP project ID and my location, which have already been set as variables. And so, so once I've done that, I can go ahead and start writing some code. So in this particular case, whenever you're calling the Gemini models, all you really need to do is pass along just call client.models.generate content, and then you pass along the model ID. In my particular case, the model ID is defined up here. You can see Gemini 2.5 flash preview, right? That's the model ID that I'm going to be using for a lot of my code samples here. And so yeah, so let's go ahead and kind of continue here. So once I go ahead and run this, you're going to see a response, right, object that gets passed along, and we're going to render its text property in Markdown format. So let's go ahead and run it and see what happens. In this particular case, I'm asking the question, briefly explain what is an AI agent. And if I did things right, the code will run, and you will see what an AI agent is. Okay, and so that's
from this point, essentially, you did the whole setup, right? Getting access to the model, providing, that you have the API key. Right now, are you using AI Studio, right?
In this case, I am using a GCP project. So I'm not using an AI Studio API key, but you can if you want to. If you notice here in my secret, I've actually disabled the API key. So I am relying exclusively on the application default credentials, which is part of Google Cloud, and that's how I'm authenticating.
Beautiful.
Yeah. So as you can see, the model is responding, right? And so it's giving me what I want. So that's the first kind of lesson. It's just simply, how do I call the model? It is very straightforward. You call this particular function, you will get a response object. And that response object includes a property called text, which lets you quickly and easily access the content of the
They're
message.
making it so
However,
much
there's a
smoother.
lot more to that particular response object. And so I'd like to kind of give you an example of what that looks like. And the way we can do that is that we can leverage a feature of the SDK, which which this SDK makes very heavy use of what's called a library called Pydantic. And Pydantic lets you define structured data classes. And one of the features of Pydantic is that you can always dump the data. I say dump it, but output the data or access the data and print it out as JSON. And that's what I'm going to do here. I'm going to take that same response object. I'm going to go ahead and dump it in JSON format, and we can see that the response object is this big structure that contains a lot of information. Among them, you're going to see this contents section, which in turn is split into parts.
Mm-hmm.
And these parts, the first one here has and the only one, has a text attribute, right? And it has the actual text response. So when earlier we were doing response.text, it's just a shortcut for accessing response.candidates.content.parts
Oh, okay. It knows
sub-zero
how to go down in there and find that specific
text, right?
field.
And so that's it. So that is the output of the content.
I'm not mad at
So
that.
let's go ahead and keep looking here and call out a couple other interesting attributes that are being shared. One of them is usage metadata.
Mm-hmm.
Let's face it, invoking a model costs money, right? And so as you think forward to implementing an agent and putting it into
Excuse me.
production, it is useful to understand how much it costs you to actually execute an agent or execute a model call or anything along those lines. And so when we look at the usage metadata, we're going to see that how many tokens we're we're consuming. And in this particular case, we're consuming 134 tokens of output plus 10 tokens for input, and that in total equates to like fractions of a penny in terms of cost. And that is because of the way that that all large language models, whether it's from OpenAI, Anthropic, or Google Cloud, are priced. It is usually some kind of a function of a per token basis. Okay, so let's kind of keep going. So the point here is that the response object returns a lot of useful information. The main one we're going to be using on a regular basis is going to be response.text, right? And that's usually what we care about under most circumstances. When we're developing agents, it's going to get a little bit funky, a little bit interesting. So I mentioned previously that in the context of as one trains models and they do what's called reinforcement training, they teach these models to be more than just text simulators, right, or text predictors. They get trained to be able to do to answer questions, right, to have reasoning. To basically reason over things. And among the other kinds of things they get trained for is to invoke what's called a function, or some people also call it tools. So I will be using that term interchangeably. So the first thing we want to do is we want to test how to make my my model call a function is to define a function that I can invoke. And so that's what we're going to do here. So I'm defining a function called getCurrentWeather, and this simulates calling some kind of an external API that can return the weather for a particular city. I'm simulating this. So in reality, what I've done is I've defined an array of possible weather conditions, and I'm just going to randomly select one of those weather conditions and return it as its output.
And I think there's a slight confusion, Luis. I
Yes.
think just to make sure, right, you're using right now a collab that is empty, right?
This is an empty collab, exactly.
Yeah.
The one that is
I have the
that
link, so I'll share again to the audience so that they know, like, hey, the final product of this code, right, could be found in the link that I have
exactly.
right
This
now.
is the final product. Exactly right. So keep in mind, all I'm doing is I'm copy pasting just to avoid visual clutter and visual noise, and so that I can explain things step by step. Okay. And I did see some comments that some people might be feeling a little bit lost and whatnot. Once again, there is a much lengthier session that we did in Q1 that goes into greater detail. So in the spirit of making sure that we have enough time to cover agents, we do have to kind of noise, and so that I can, and this simulates calling some kind more than just when we're developing agents, it's going to get equates to like fractions of a penny in those lines. And so when we look at the usage metadata, we're going to see that how many tokens we're using, we're consuming. And this particular in this particular case, we're consuming 134 tokens of output plus 10 tokens for input, and that
Do they have a
in
total?
total
Oh yeah, total token count.
equates to like fractions
No,
of a
it's not
penny in
total
terms of
token
cost. And that
count.
is because of the way that all large language models, whether it's from OpenAI, Anthropic, or Google Cloud, are priced. It is usually some kind of a function of a per token basis. Okay, so let's kind of keep going. So the point here is that the response object returns a lot of useful information. The main one we're going to be using on a regular basis is going to be response.text, right? And that's usually what we care about under most circumstances. When we're developing agents, it's going to get a little bit funky, a little bit interesting. So I mentioned previously that in the context of as one trains models and they do what's called reinforcement training, they teach these models to be more than just text simulators, right, or text predictors. They get trained to be able to do to answer questions, right, to have reasoning. To basically reason over things, and among the other kinds of things they get trained for is to invoke what's called a function, or some people also call it tools. So I will be using that term interchangeably. So the first thing we want to do is we want to test how to make my my model call a function is to define a function that I can invoke. And so that's what we're going to do here. So I'm defining a function called getCurrentWeather, and this simulates calling some kind of an external API that can return the weather for a particular city. I'm simulating this. So in reality, what I've done is I've defined an array of possible weather conditions, and I'm just going to randomly select one of those weather conditions and return it as its output.
And I think there's a slight confusion, Luis. I
Yes.
think just to make sure, right, you're using right now a collab that is empty, right?
This is an empty collab, exactly.
Yeah.
The one that is
I have the
that
link, so I'll share again to the audience so that they know, like, hey, the final product of this code, right, could be found in the link that I have
exactly.
right
This
now.
is the final product. Exactly right. So keep in mind, all I'm doing is I'm copy pasting just to avoid visual clutter and visual noise, and so that I can explain things step by step. Okay.
Yeah.
And I did see some comments that some people might be feeling a little bit lost and whatnot. Once again, there is a much lengthier session that we did in Q1.
Some people
that
probably
goes into
do not
greater
have enough
detail.
prereqs
So
to
in the
be in
spirit
this
of
sessions.
making sure that we have enough time to cover agents.
One thing
we
I
do
will
have
say is like, cause I know, I be on like the ML bandwagon and stuff like that, cause that's what I'm personally working on. But like, um, definitely, if you are trying to get into agent building, like actually building agents at this point, if you are not already familiar with how language models work, large language models, if you haven't like worked with any like APIs or like built a chat app with an existing model, you want to start there. Honestly, hold on, let me see. Cloud on Air. And this is like the third AI startup school that I know of for sure. Hold on, let me plug up my camera. Okay. Let me take this little quick detour just because I also don't want people to be confused that want to get into learning about agents. Agents is not a beginner topic for AI right now. Like you need to at least understand how large language models work and being comfortable and familiar with working with like the large language model APIs and things like that at the very least. Because agents are like building on top of those concepts. So that being said, let me see. Do they have it under here? I want to try to find the other they had a Q1. Let me see if I could just change this link. And I did one last year. The one we did last year was just they were just covering large language models. Like it was generative AI. It was a generative AI one actually. So this is they did it again. Yeah, this is the one that you want to do first. This and it's much longer too. It's like at least two. It's probably at least two extra sessions in here, 2 to 4 extra sessions. Um, Copy. I'm gonna put this in the Discord because yeah, you definitely need to go through that first. Um, if you're already familiar, then you can kind of jump in, but it's a lot to take on. Let me see. For anyone that has not worked with generative AI or LLM applications before, please start here before jumping into agentic AI systems. Um, okay. AI ML channel. AI ML channel. Okay. I am
Have
gonna
to kind
speed
of
this up because I want to
make
hear
that
it,
first
but
section
I'm coming
brief,
back to
right,
this
as to how to
again. I'm
call
gonna
an
watch this
agent,
again today.
excuse me, how to call a model, and we're going to jump straight into the core building block of agents, which is function calling, which is what we're doing right now, right? So, as I said before, we create a function that returns randomly selected weather. All right. The next thing we need to do is that we need to actually tell the model that it has that function available, right?
Oop,
uh,
wrong direction.
and that it can invoke it. Okay, and so the way that we do that is that we first create a tool belt, right? We create a Python list of any number of functions that the model could invoke at a later point in time. For some of the questions that are coming, this is notebook number 2. So we're defining a function, excuse me, a tools list that contains a reference to the get current weather function that we defined up here. Okay, so once we do that, the next thing we need to do is wrap it inside a configuration object that will be used by the model to understand that that function is available.
Yeah,
And
your
along with that,
tools and
just
then
for fun, I'm
config
adding a system
is.
instruction telling the model to return its output in a rhyme. So I'm just going to have it rhyme just because it's fun. All right. So next we do something that we've already done previously, which is to call that generate content function, passing along that model ID of Gemini, right? And we're going to ask it the question, what is the weather like in Boston, Massachusetts? Okay. I executed that cell before executing the previous one. So let's do that real quick. There we go. And now I am calling the model. The model comes back to us. Um, and the model returns back to us and it returns a value of overcast. And then the model is saying the weather in Boston, I now can disclose, is overcast as the current report shows. So
So right
Config
here, Luis,
response.
the model that you're calling, right? Why would it need the function calling mechanism to answer this, right? Can't these models now
right,
just
yeah,
answer
let's
this?
understand what's going on here. Thank you for asking. So remember the slide that said that and when Abe discussed that models are trained on the contents of the internet, right?
Mhm.
And the model, a large language model, think of it as a lossy, compressed version of the entirety of the internet. Okay, what do we mean by lossy? Well, the internet is probably thousands of petabytes worth of content. It's a lot, and the large language model kind of tries to condense all that and compress it into something that fits in a few gigabytes to several hundred gigabytes in size, right?
Mhm.
So and that's because all it's doing is learning how to predict the next sequence in a sentence. The point here is that all that knowledge, all that wisdom that the model acquired from this information on the internet is cut off at a certain date,
Mhm.
right? So in other words, at some point, somebody went out and crawled the entire internet, saved all the content, gave it to the model, and from that date on, the model does not know anything. Like if I were to ask older versions of Gemini, tell me about the Pixel 8 as an example, it might not know that the Pixel 8 exists because
Mhm.
it was trained on data that existed before the release of the Pixel 8,
I
right?
see.
As an example. And so let's apply this to then why we need function calling. Function calling is a type of what's called grounding. Grounding is when we can add additional information to the model that is more current and is applicable to whatever it is that we want the model to do. Okay,
I see.
and so that information now can be used by the model in order to generate what we call grounded content, right? Grounded information, which is grounded on some additional facts that came from the result of having invoked a function or a tool.
I see. And knowing that, for example, Gemini 2.5, which you're using, I think their cutoff date is January, right? So it's going to be hard for it to know, today's date in Boston, Massachusetts.
Right, exactly. It does not know today's date. It does not know today's weather. It does not know even this week. Apple is doing WWDC, for example, so it might not know about iOS 26 or Mac OS 26, right?
I see.
And so like that current information can only be achieved by giving the model and really the tools around it some capability to talk to the outside world.
Makes
And
sense.
that is going back to kind of the core principle of this particular session. That is at the heart of what an agent needs to be able to do. It needs to talk and interact with the quote unquote outside world.
Yeah. Or else it's stuck in that snapshot period.
Exactly. It is read only, right? It can only just share what it knows. And what it knows is not only old, but because it's a lossy kind of like a compression, if you will, the model could be prone to hallucinate. And that is an expression that is used to kind of say that the model will make things up, right? And so we want to avoid that. And there's a lot that Google DeepMind does in order to ensure that our models are less likely to hallucinate, but it's still possible, right? And so this ability to call functions and interact with the outside world is one mechanism that we give the model and the tooling, such as the SDK that we're using.
I don't know if I can turn the audio up for y'all. It's as high as it could be in the broadcast software without clipping. I'm able to hear it on my other device. You might want to turn it up though, but I can't turn it beyond this. If you want to watch this live, it's cloudonair.withgoogle.com. This is Startup School Q2. So they're actually live right now.
It's one mechanism that allows the model and the model's output to be relevant and to be factually correct.
Mm-hmm. Perfect. No, this helps. And then the way that you call it right in the code is you strictly say, hey, there's this current weather function. This is the tool. Oh, right there. Perfect.
Exactly. So we're saying, hey, you have a set of tools. Actually, I could actually replace this with just tools, right? So you have a set of tools available, which includes, in this case, it's just one tool, the get current weather function. And what's happening under the hood is that we send a request to the model, and that request includes some additional metadata that includes the function declaration. And we're leveraging some Python trickery, if you will, where Python has a feature called metaprogramming, which allows it to inspect itself. It's called reflection and introspection. And so it can look at the get current weather definition function, and it can basically express or represent it in a way that the model understands as text, right? And it basically says, hey, you have access to a function called get current weather, which accepts a location, which is a string, and you can expect it to return the weather conditions for that location, right? And so the model returns back to us. And in fact, let's go ahead and jump to the next part for a moment, because we're going to see what's going to happen. So the model basically says, hey, I don't know what the weather in Boston is, but I see that I have access to a tool called Get Current Weather. I'm going to return a request for the client, which in this case, the client is the code that's running inside my notebook, to first invoke that function with the parameter of Boston, right? And I'm going to wait for that function call to return. And then that function is then going to be, the results of that function is going to be used to generate the final answer. And how do we know this is happening? Because in the response object, where it says, the weather is overcast and so forth, right? In the response, there is some additional metadata called automatic function calling history. And if I print that out, we're going to see hidden in there this. And what you're seeing there, just to kind of elaborate on this, is that the model told the client, hey, I want you to execute a function called get current weather and pass along a string called Boston, Massachusetts to the location argument.
Okay. So I think the next question that most people are going to have is, how does the model know to use get current weather? For example, let's say you had get, the current stock of, company A. How would the model know to use like, oh, this is a weather response that I should provide, or this is a stock response that I should provide?
Yeah. So remember what I mentioned about metaprogramming, and we could go in and spend like 2 hours just talking about metaprogramming. But what it really boils down to is that Python, Java, and many other programming languages allow essentially the metadata of the function to include things like its documentation, its properties, its variables, and everything else. So in actuality, for simplicity, you can think of it this way: we're basically copying the function, right? Really, it's documentation, right? And whatnot. We're copying that data and sending it to the model as text, right? And so the model, because of the way that it has been trained, right? It understands, it can read the documentation. It can basically say, I know that this is the function I'm going to use if I need to look for the weather. If I had another function that looks up the latest stock prices, right, then we could, it could kind of decide on its own, okay, the customer or the user is really clearly asking for the stock price of Google stock, right, or Alphabet stock. Let's go ahead and look and use that function to call it. And actually, a little bit later, you're going to see me share two functions with with the model, and I'm going to show how it can that it decides which one is appropriate for which kind of request. Okay.
Yeah.
All
Okay.
right. Cool. So let's kind of keep going here. I think in the interest of time, the notebook number 2 includes manual function calling, just to dive deeper into that topic. I'm going to leave that as an exercise because really, in our case, we're leveraging automatic function calling where the SDK just can interpret the instructions from the model as an instruction to call the function on its behalf and return the results.
Okay.
And so, yeah, go ahead.
Oh, no, sorry. I was just saying, okay.
Yeah. And so what we're going to instead do is that we're going to jump into that example where we're going to pass along two different tools, right? And we're going to see the model use the right tool for the job. Okay.
Okay.
All right. So the Google Generative AI SDK includes two special tools that are Google Search, right, and a tool called URL Context. Okay.
And these two tools are like functions that are written by Google, managed by Google. All you're doing is saying, hey, AI, I want you to use these two different tools as my agent.
Exactly. So so I am now initializing my tools list with those two tools, right? Okay, so I'm initializing those two, and I'm going to wrap them inside a configuration, and I'm going to prompt the model, where can I buy pool furniture near San Jose, California? And the best way to answer this is by executing a Google search. So let's go ahead and run it and see what happens.
Okay. Where can I buy pool furniture near San Jose, California?
All right, and so what happened is that the model knows that it has access to two tools. URL context lets it browse websites, but the really useful one is the Google search one. And it's going to use Google search to get up-to-date current information about stores in San Jose. One way we can actually kind of show that what the difference is that look, what happens if we disable the tool by removing the configuration for a moment and have it just answer? And what we're going to see is, in theory, different results because it is unable to actually execute a Google search. So it's going to make information up. All right. So
yeah, because the base model, the best it could do, right, is sort of give you the more than likely response, right?
Yeah.
Whereas when you call the tool, you're actually calling Google search as a backing to sort of ground your knowledge base in search.
Correct. So now, because the models have gotten very sophisticated and we're using Gemini 2.5, the model is giving me very factual information, right? It's telling me I can go to Home Depot or Lowe's or Target and Walmart. It even tells me where some of these stores are located, right?
Yeah.
And that's just because it's leveraging its very large, basically, corpus
big
of knowledge to answer the question, but it actually doesn't know in detail. That's why the answer that it gave me when it was able to execute Google search, it was able to return something that was far more actionable, right? And even the way it's formatted, you can tell that this is, and you can intuitively tell that this is giving me very quick, not very quick, a very kind of like relevant output that is very specific to what's around San Jose, right? So that's the model choosing to use Google search for grounding. Now, without making any configuration changes, right? So giving it, once again, these two tools to look at, right? I'm going to ask the model to give me the headlines of this website, right? And so I'm going to go ahead and run it, and then I'm going to share a tab for a moment. And so this is the website that it's browsing, right? And notice the headlines. As of June 11th, this company, or whatever, it tells you that there's certain news about Meta, Lamini, Instacart, and so forth and so on, right? So these are the top headlines. And if we now transition over to the notebook one more time, we're going to see exactly that. We see up-to-date current information that is being loaded by the model, really by the tooling around the model, to retrieve the contents of this website, and then it's going to briefly summarize the different headlines that appear in that website.
I see. So essentially what you're doing with the tools, right, is you have the base model, which is Gemini 2.5.
Yes.
And you're giving it access to these tools to add to sort of the big brain that it has.
Yeah.
And it's still, Gemini 2.5 is still in there. It's still producing this as an answer, but now it knows, hey, I could go access this news.small.ai website. I could get the context from that website and then add it to sort of the big base brain model that I have.
Exactly.
And it's useful. And I think what's important to call out is that if you don't tell Gemini 2.5 to use the tool, it's not going to use it.
It's not going to use it. It's not going to know it exists, right? And so it is limited by its own, just everything that it knows, right? Which fortunately, nowadays the models are really, really good. I mean, this is really cool stuff, right?
Yeah.
And it just shows that we are, that the advancements that are happening in this space are only accelerating, and that something that was next to, I'm not quite impossible, but very of limited value and use even 6 months ago has gotten dramatically better over
Yeah.
time.
Yeah, because
So,
I just
yeah,
heard recently we launched grounding in Google Maps. I'm not expecting
exactly.
to have a demo of that right now, but again, you could ground localized data using Google Maps as a tool. So
That's
Gemini
right.
2.5 may not know latitude and longitudes of every single business out there, but now you could give it that power.
Exactly. So, and that type of grounding with maps, the model not only needs to be able to kind of understand latitude, longitude, and everything else, it needs to be able to understand distances and routes and other types of information that that requires far more, I'm going to say, quote unquote, intelligence, right? More thoughtfulness in order to interpret.
Yeah.
Okay. So now let's move to kind of the second part, and where we're going to try to apply the lessons that we've learned about invoking models and this idea of function calling or tool calling, right? And put it together to create something a little bit more sophisticated, an agent that can perform more complex actions on our behalf. Okay. Now, part of my goal here is to expose teach you how an engine works before we build a car around it, right? And the reason for this is that next week and the weeks that follow, we will be showing you SDKs and SDK software development kits, right? SDKs and whatnot that provide a lot more functionality for you. But I'm a firm believer that one has to understand the basics of say internal combustion engines in order to understand what kind of capabilities say a sports car would have versus a school bus, right? And so that's kind of my point of view here. And so what I'm going to try to teach you is by using just the basic Google Gen AI SDK, how we can begin the process of thinking agentically. And then when we start exploring the more full-featured tools like the Agent Development Kit, which we will briefly talk about today, and will be other colleagues of ours, other presenters will be diving into in greater depth, you will understand to a greater degree what's happening under the hood, what the Agent Developer Kit is doing on your behalf to make it easier to develop agents. So in many respects, this is more low level than what you're going to be using on a day-to-day basis. But once again, the point here is to teach you how something is built from scratch so that you can appreciate then the effort that the developers of tools like the Agent Developer Kit went through in order to make it more ergonomic for you. Okay. So yeah, so let's kind of talk about the evolution of AI agents, right? First, we started with just having a large language model and a prompt, right? And that's effectively what we did in the first couple of examples, right? Next, we added effectively function calling, right? But the ability to do retrieval, right? And that retrieval, for example, the Google search example, right, is the ability to kind of get information from somewhere else that is relevant to whatever the model has been asked to do, and feed that information to the model so that the model's knowledge is updated, right? It's kept up to date, right? And so that's kind of what's happened. Next, we have added more sophistication around the use of functions and tools to allow the model to actually perform sophisticated actions. And we've seen this in the industry. We've seen, for example, Google's Project Mariner is an agentic web browser, right? A web browser extension where you can tell Mariner/Gemini, which is what's powering it under the hood. You can say, hey, browse this website, look for all products related to this, right? So in other words, I can have it go to Amazon and look for pool furniture, and then give me a list of some of the best rated pool furniture at the lowest price, right? So I can do that.
And I think before you go to this one, right, I think what's important to note is that all of the agents that are out there, right, that, for example, that Google's making, it all starts with that base model, which is the blue little button right there.
Exactly.
Right? And you as a developer, as an engineer, right, you have to integrate the RAG, the green button, right, the tools, right, the orange yellow button, but then also maybe that sort of loop of like multiple tools, multiple RAG components, multiple retrieval. It gets hard to orchestrate. But I think what's important to know is that the base model, right, is sort of your starting point. And you could have a successful business or startup or anything like that that is just focused on the model and prompting, and that's it. But as sort of the years have gone by, right, there's been higher and higher expectations of leveraging retrieval, like the Google search example you provided, but also the tools mechanism.
Exactly. Yeah. So so if we remember, what was it? Google Bard, for example, right? These two are basically the Bard era or the GPT 2.0 era, right?
Yeah.
As an example, we are now in this second era where we have a lot more sophistication, right? And so this many tools and reasoning loop takes the idea of taking an LLM and giving it access to retrieve information from other places and to execute actions on your behalf and add them to a loop. Right. And a loop is important, right? Because think about the way that we as humans accomplish tasks, right? If we are presented with a complex task, such as assembling IKEA furniture, right, as an example, we're going to be, we will come up with a plan. And that plan, among other things, includes let's read the instructions. Let's understand the instructions. Then the instructions themselves are part of the plan because they have step 1, step 2, step 3, right? And so as a human, I essentially enter a loop. right? Where that loop is basically, okay, come up with a plan, read the instructions, understand the instructions, then go through every step of the instructions one by one, repeating kind of my loop to make sure that I am going step by step by step, right? And so that's where, that's taking us to a world where these model invocations, these calls to the model, become more than just a single request and response, and we start kind of performing sophisticated actions. And finally, we get to a world where we have many agents operating in loops, right? Potentially collaborating with each other because each of them might be optimized to be an expert in a particular domain. There could be a model that is very good, excuse me, I say a model, I meant an agent that is very good at making airline reservations, right? And another agent that is really good at purchasing clothes appropriate for the weather in a particular city that you might wish to visit as you go through the process of, reserving a flight, right? And another agent could be a very good vacation planner. And those three together could collaborate to basically plan your vacation, buy you clothes that might be appropriate for the weather at that location, right? And book your airline and hotel reservations and so forth and so on.
Wow,
Right?
yeah, it's a lot of nested functionality here now, right?
Yeah.
Like going back to the left, right, you have the model, then you have the tools in the model, then you have multiple models and tools talking together, and now you have sort of this one agent trying to communicate to a whole other agent, right? Which still has the core components, which I guess I see what you mean by like understanding how the car is made, right? Really helps the bigger picture and solve these much more challenging problems that agents could.
Yeah, because in many respects, what we're seeing on the right-hand side of this slide, these are high-level abstractions for this low-level stuff that I'm showing you. And yes, as developers, we can choose not to be aware or not to think too much about what's happening under the hood. But when a problem arises, that foundational knowledge will absolutely be crucial in helping us as developers and architects and designers and so forth find a solution. Yeah. Right. Otherwise, we're going to be left asking ourselves the question. It's like, like I don't know what to do, and we probably will end up having to learn the things that I'm already kind of talking about. Right. So we see this evolution, and so the natural question is like, what comes next? Well, I don't have necessarily an answer to that, other than we're going to see increasing levels of sophistication. Right. And yeah. Did you have a comment or question, Abe?
No, keep on.
Cool. So essentially, what we're really saying is that as these higher level orders of abstraction come into play, these more sophisticated toolkits and runtime platforms and cloud services and stuff like that come into play, we see then that the need for additional tooling, right? And this includes some a collection of tools that you see there on the left-hand side of the diagram, right? A collection of tools. You see a runtime, a place where the code is going to be executing. And you're going to need some kind of orchestrator. An orchestrator is responsible for making sure that the steps of the plan are executed in order. Models, because they're effectively read-only, right? They don't have memory, so you need to give the model some type of ability to remember what it did before, right? And you need to be able to leverage the right model for the job. Sometimes a very powerful, expensive model is necessary, but other times a faster, more affordable model could give you just as much quality at a higher performance and lower cost, right? And that's what you're seeing on the right-hand side is this idea that the right model for the job can be selected. And then finally, the whole point here is to serve the user, and that's what you're seeing at the top. It's this idea that the user ultimately will issue a query, which gets executed by the runtime, orchestrated by the orchestrator, which is leveraging a combination of tools and models and memory to give you your response, right? And that executes in a loop, which is a reason, plan, and execution type of loop, right? Now, there are many ways to architect agents, and there's no single right way. One needs to consider the type of job that you want your agent to do in order to decide how to architect it. We're going to focus today primarily on single agent architectures, where we're going to have a single agent that is going to be good at doing one thing. But over time, you might want to link these individual agents with each other to create something more sophisticated, like that vacation example that I gave you earlier, right? And that might be a multi-agent architecture. And each of these have their pros and cons, right? And challenges. Basically, the more components you add, the more sophisticated and complicated something becomes, and it might be more difficult to debug it and so forth. And we'll talk a little bit later about how Google Cloud and tools that we bring to the table help facilitate this. But
real quick, I think just because of time, maybe seeing the demo of the agents, as you mentioned.
That's exactly what we're going to do next.
Perfect.
So over the next 15 minutes, I'm going to show you two types of agents, and then we're going to leave 15 minutes for Q&A. So let's go ahead and jump to it. We're going to focus primarily on orchestration, which is what you're seeing in the center of this diagram. Of course, we're going to be leveraging Gemini as our LLM, and for data, we're going to be using mainly Google Search, and yeah, that's mainly it. It's going to be Google Search related. Okay, so I'm going to stop sharing this section and go back to our lab. And let's write two agents. All right. The first agent that I really wanted to show you is a sequential step-by-step type of agent. All right. So a customer of mine, like a month or two ago, came to me and asked, and basically they're in the business of appraising Pokemon cards, and not just Pokemon cards, any kind of trading card, right? And so they basically said, I want an agent that when given a photo of a collectible trading card,
Mhm.
can find the most recent pricing and give us a price estimate. Okay. And so here's an example of the kind of card that we're going to be appraising, right? And so to do this, we're going to leverage some of the really cool features of the models. And I'm not going to explain it in too great depth, but what we're going to do is leverage the structured data output, another feature of the models, to basically generate a price estimate. Okay, so we're going to basically evaluate the card, right? Extract information from it using the model's ability to handle multimodal inputs. In other words, it can look at an image, it can look at text, it can look at even video and audio, right? And understand it all and be able to generate output, right? So anyway, so this model is going to basically extract all the information from the card and generate a price estimate using Google Search as its primary tool. Okay, so the actual workflow for this starts with defining some prompts. And so this is going to be a 3-step process that we're going to implement. The first step is to just read the card. That's it. We're just going to read the card and extract the information that is displayed on that image. Okay.
Okay.
And that includes things like the, what game, what is the set, what is the title of the card, and so forth and so on. So we're just telling the model, you will be tasked with extracting information from the card. Right. Once we've extracted the information, we can drop that. The model doesn't have to remember anything because it's going to be told then that it is tasked now with evaluating the information from the collectible trading card. And this is the part that's basically going to say, hey, use Google search to find information about the card and synthesize a report about that card that includes this information, the pricing information, right? And then we have a final prompt that collects that report and generates the ultimate output that we need. And that is the actual price estimate. So it's a 3-step process. Read the card, research the card, compile the final price estimate. All right. And everything that happens after this is just a series of functions that do these things. So we have a function that can download a card image. We have a function that calls Gemini and uses that image. It's going to be passed along. It's going to be passed the image. It uses that image to call the model, right, along with the special prompt that we said that we are using for extracting data from that prompt, and it's going to respond with a structured output that corresponds to the information that we want from the card. Then we're going to have another function that appraises the card, once again calling Gemini with a different prompt, right, the appraisal instructions that includes this. And then we have a final prompt that everything that happens after this is just a series of functions that do these things. So we have a function that can download a card image. We have a function that calls Gemini and uses that image. It's going to be passed along. It's going to be passed the image. It uses that image to call the model, right, along with the special prompt that we said that we are using for extracting data from that prompt, and it's going to respond with a structured output that corresponds to the information that we want from the card. Then we're going to have another function that appraises the card, once again calling Gemini with a different prompt, right, the appraisal instructions. Right. And notice that we give it access, by the way, to Google search. Right. And using that information, it generates the final price estimate. And so these 3 functions are going to be collected into basically a sequential workflow. And that's what you're seeing in this function here. Step 1, extract the data from the card. Step 2, initiate the appraisal. Step 3, estimate the price, and that's it. And then return the data. That's what these functions do.
While this runs, and if you could scroll up.
I'm just gonna let me execute this all so that we can have that run and that we can go in and explain while the agent executes.
Perfect.
All right. Oops, I need to run these things first. So let me just go ahead and do that. It helps to execute your cards, your cells first. All right, there we go. Now it's doing it. So you wanted to see something? Yes.
Yeah. Scroll to the bottom almost. Yeah, right there. Perfect.
Yeah.
So maybe you could walk us through, right? The way that I see this, each step is a model plus perhaps some type of tooling, right?
Yes.
Base model could be an image one, I'm assuming, because you need to look at the Alakazam Pokemon card.
Yes.
Right? But then are all of them using an image model? Like how does that work? Can you walk like step by step the model that you're using and then the sort of tools that are being leveraged?
Yep. Give me a second. I think I missed something didn't execute here. So let me just try one more time here. Just make sure it runs. Okay. It might have trouble downloading, calling the model for some reason. So visibility check was unavailable. Please retry the request or contact support if the problem persists. All right. So yeah, what I might do is switch the model out a little bit later. But go ahead. So you going back to your question. Say, ask one more time.
So looking at these steps, right? The way it seems is like each step is its own type of base model plus its own tooling, right? That's either so can you walk like through each step? What is the model that you're using? What tool?
Yeah. In all cases, I'm using the exact same model, and so that's what's being passed along in the variable model ID. So this is Gemini 2.5 Flash, right? The latest version. right? And so you're seeing that here. I could switch models, like and use Pro, for example, right? And so in fact, if I change my model ID, I can do that. So for example, oops, I'm executing this instead of editing it. Apologies for that. Let me just add here. I'm going to say model underscore ID equals Gemini dash 2.0 dash flash. So we'll give that a shot just in case, and hopefully it'll work. So anyway, but yes, you can actually mix and match models. Right now, once again, my example is simple. All I'm doing is just using the same model for everything.
I
Okay.
see. Okay.
All right. So yeah, so I'm still having a little bit of a problem here. Maybe it did not. Please, this is an odd error. So I'm going to have to look. So what I'm going to do is I'm just going to show you the previously executed run of this, just to kind of show what happens. Okay. So what you're seeing here is the previous run, right? And the first thing that I'm doing is printing out the appraisal text. This is just what happened after initial Google search. It's a brief report. Okay. So this brief report says this is a first edition thin stamp holographic Alakazam, and here is some of the information I was able to retrieve and so forth about it. The next, these are the structured versions, and this can go into a database, right? And that's really the use case that my customer had. It's like, I want to be able to get the latest pricing and I want to store it into a database, right? And this here is the complete structured data set that represents all the information that was retrieved from the card, right? And I print out the picture just to do a sanity check. So that is what's happening there. All right. So we've got about 20 minutes left, and so there's just enough time to talk about a looping agent. Okay. So as we saw before, the trading card appraisal agent just goes through step 1, step 2, step 2, step 3, and then it's done. Right. That's just a serialized workflow. But we can create a research agent in this case that uses a loop to think through what it learns as I ask it to research a subject, right? And ask follow-up questions and do that a certain number of times until either A, the model is satisfied that it has thoroughly researched the topic, or B, the loop has executed up to a certain maximum number of iterations. Okay. And so to do this, we start again, like before, with the idea of different prompts for different tasks or parts of the process. So the first one is, hey, you are responsible for essentially inquiring, right? And doing, when a customer gives you a query, go ahead and research it. All right. And I want you to use citations. I want you to output 2 primary things. Number 1 is a detailed synthesis of the information the model discovered. And then the second thing I wanted to generate is a list of questions. Okay, follow-up questions, so it can research again in the next loop iteration. If the model believes that research is complete, I tell it to write finished inside the questions part of the response. Okay, we'll see how that comes together in a moment. The next prompt is, I need you to now use everything you have learned to generate your final report. And your final report should include an executive summary, an introduction, detailed findings, and so forth and so on, right? And so, it's just going to format the report. Now we can define a research agent that executes a loop, right? And so everything for this agent is contained in this one function called research agent, but you're going to see multiple different model calls, right? For the different parts of the thinking process and the research process, right? So let's go ahead and take a quick look here. First, we're going to define the tools we're going to use. Just as before, we're going to use Google search and URL context. Realistically, URL context is rarely going to get used, but we give the model the option to use it just in case. We're going to, as before, generate our tool belt, right? Our configuration, and we're going to include as a system instruction the research prompt, right? So remember, that is, go ahead and do initial research and then decide whether or not you're going to ask follow-up questions, right? We're going to give the model memory, and memory is represented here as a list of previously generated content, right? And so, we're not going to go into too deep details as to what the structure of this is, but essentially, we're just using the exact same data model that the SDK uses, right, to format requests and responses, and we're just going to append that to an array, so it becomes, think of it as a chat history, right, of everything that we've been discussing. So whenever you use Gemini.google.com or something like that, where you're chatting with the model over the course of several iterations or turns, as they're called, all you're doing is appending to the memory, right? And so here we start our loop. We're going to output what turn it is, and we're going to basically say, okay, now call the model, right? Using the memory, using the function calling configuration and all that. And I want you to extract the context. I want you to look at the synthesis section and the questions, store them in these variables, right? I want you to also extract the grounding metadata, which we don't actually use at the moment, but it's for debugging purposes, right? And then I wanted to determine whether or not it has finished, right? And then what I do, instead of outputting all that information, I actually use Gemini 2.0 Flash Lite, which is a very small, fast model, to briefly summarize everything it learned and what it's going to do next, right? And it's going to repeat that process. And once it's done, like, remember, it's going to do this up to max iterations, right? Once it's done or it decides it's finished, then we're going to run one more invocation where we say, hey, now use the final report prompt. We're going to change a parameter called temperature, and temperature relates to creativity or randomness, right? So we're going to make the model very uncreative, right? We're going to say, Don't make things up, right? And we're going to pass along that information to Gemini Pro, right? 2.5 Pro, and it's going to generate our final report. Okay. So when I ask it, for example, research the various techniques for architecting generative AI agents, and I tell it in this case for simplicity and brevity to loop only twice, right? It's going to output this information. It says, hey, I did my initial search and I have learned about architectural concepts and so forth and so on, right? And then it's going to ask these follow-up questions. And then after the follow-up questions, it outputs these additional data points. And I'm going to skip this this run here. I'm just going to scroll down a little bit further because I have compiled here a sample output of my report. Okay. And so this is what it generated after, in this particular case, this example ran like 8 turns, right? And so it generates a very thorough review, including links to sources, right, of what it takes to architect generative AI agents. Not only does it give you this very comprehensive report at the bottom, and we're just going to scroll down all the way to the bottom, we get a list of citations. But the point here is this is a different kind of agent. Instead of executing things step 1, step 2, step 3, and then it's done, this is going to repeat a series of steps over and over again until it's done, right? Until it decides it's done, or we loop a certain maximum number of times. And so with that, we can return back to our slide deck and just kind of conclude. Okay. So go ahead.
No. I think, yeah, let's, and then I want to put time to do sort of the Q&A.
Yeah. So we're just going to leave it at this, I think, to allow time for the Q&A. Google Cloud provides a very comprehensive platform on top of which you are going to be able to not just initially develop your agents, right, but also to run them at scale and do so, securely and be able to properly monitor it and everything else. At the heart of a lot of this is Vertex AI. And the Vertex AI platform offers, that's where you're going to be able to access not just Gemini, but hundreds of models from both Google and other parties such as Anthropic and Mistral and a bunch of open models and so forth and so on. Vertex also gives you a platform called Agent Engine, which is like it's a version of Cloud Run that is optimized to execute agents and provide them with session management and memory. Remember that I mentioned that models have no real memory in and of themselves, so we need to give them some ability to quote unquote remember things. And so think of it as a lightweight database that records past actions. In addition to that, you need to be able to observe what's happening with your models, and so logging and monitoring is important. And we within Google Cloud offer a comprehensive platform that allows you to add observability features to your applications, and that of course naturally includes your agents. As a developer, it's one thing to develop a very basic kind of an agent that you're going to run on your own, but if you're building a startup around this, then you are probably going to be collaborating with other developers. And for this, you need CI/CD, right? Continuous integration, continuous delivery infrastructure, and we support this through our various different cloud operations and CI/CD tools. All this then gets executed within a runtime, like I mentioned before, and ultimately allows you to deliver a high quality product to your end customers. So with that, I think what we can do is jump over to questions over the next 10 minutes, and then we'll pass the ball over to Erin so that she can wrap us up. So let's start with questions.
Yeah. Thanks so much.
Awesome. Thank you guys so much. We've got a lot of questions from the crowd, so I'll go one by one and we'll see how we do and how many we can get through.
Excellent.
All right. So first one, in designing multi-agent architectures, what are Google's best practices for balancing task specialization, so using multiple sub-agents, versus building a single general purpose agent, especially for startups working with limited resources?
Yeah. So I'll start with a little anecdote or statement, and that is that Abe and I are what's called customer engineers. In the industry, we call ourselves sales engineers. And one of our favorite answers to any question is it depends. But to dive into greater detail, it boils down to evaluations, right? In other words, when you develop any code, whether it's just standard procedural code or agentic code or anything like that, one needs to evaluate the quality of the output along with other metrics such as speed, cost, etc., versus other alternatives, and that's going to help you make an informed decision. So frankly, it requires experimentation and iteration, right? Along with all that, I will say trust your intuition first, right? Intuition usually gets us pretty far, right? And I would also caution against what I would describe as premature optimization, right? That's when we obsess over it's like squeezing every ounce of performance out of something. It's best to develop something quickly, make sure you get a good handle of how well it performs. And then
This is the Google AI startup school.
So that's kind of
so they're talking about like how to build AI agents.
The CEO of Cohere thinks that his name's Aiden Gomez, no relationship to him. He said that if we
so yeah, that's what I'm working on right now. But
today, this is as good as they get. No one's gonna
I was saying, I actually posted the links in the Discord. I think you got into Discord, right?
Just the complexity
in the AI ML channel.
Solution gets very
I think you're
complex, right?
already.
Things like RAG,
Oh,
things like
why do I feel
function
like you
calling.
might
It's not
already be in
easy stuff, and there's
Discord?
still a
Let
lot
me
of work
see.
to sort of orchestrate and do this better. And I do believe the next sessions do talk a little bit more of tools that
Okay,
we
but
have
even
that are
if you're
open
not,
source for this sort of agent, sub-agent
yeah.
orchestration.
You're already in Discord.
What Luis shared today, sorry, was just the
In the
raw code
AI
itself,
ML
but he didn't
channel,
add any orchestration,
here
not
I'll
any
tag
centralized user.
you.
He actually chose the more difficult path.
I
Exactly.
forgot what it was called.
Exactly. I
It's
chose the hard
okay.
path on purpose to teach
Well, I
orchestration
don't know if
as well.
you'll
But
see it.
the
It's
different
just
methodologies
it's
are
called the
changed.
Nerd
Next
Series.
question.
That's my fault,
Awesome.
huh?
All right.
Because
Can the function provide
it's
internal
not even
enterprise
like
information to
named
the
after
model?
me.
So to ground the facts with enterprise context.
Absolutely. And
But
that's essentially what grounding is. It's a
it's
function
a
call
pink
that
icon with
queries
a
anything,
girl with like
right?
two
So
little
it either performs a
pink
mathematical
buns.
calculation like, hey, is this a binary? No.
Um,
Or at that point, you can call a database, right? And get
but
information from the
yeah,
enterprise
this is the
repositories, right?
Google AI
You can
startup
call an
school.
enterprise search index, right?
So I'm getting into like agentic systems as they call them. But if you have ever used like like ChatGPT and things like that, pretty much the tools that you use to have these like chatbots, now the tools have advanced enough that they kind of can, like, it's opening up like a new version of programming, if that makes sense, or new types of applications I think that we can build that we couldn't do in the past. So like most of the language models now can, they have a lot of information. They have the entire like World Wide Web in their memory. They understand, like, they have like kind of gone over all the documents we have on the internet. And then now a lot of those models are also multimodal, meaning like they can work with text, they can work with images, they can work with video, and they can natively output in all of those formats at this point typically as well. So yeah, it's a lot of things. Like now, if you just think of that as like its own little component, you can create different agents that know how to like perform specific tasks, get them all to interact with each other. And yeah, it just basically allows us to, is like opening up a new area of software. I think just different type of applications that we can do that we couldn't do in the past, at least not programmatically. So I've been learning how to build like agentic systems out, because there's certain type of applications that I've wanted to build over the years that would have been either impossible or very, very, very hard to do, um that are like now pretty not straightforward, but straightforward-ish, using like some of the capabilities of the language models that we have. So I don't know, I'm very interested in this, but I was saying earlier, like, if you don't have any experience with working with the language models and like maybe even like using APIs and stuff, and you want to start with like how those work, then the Q1 startup school that they did, I just posted the link to the Q1 startup school in the channel. So that one starts with generative AI. Like, what is generative AI? So like ChatGPT and Gemini and all those tools, fall under that category. And I went through this material last year. I might go back through the one that they did earlier this year, because it's got a lot of updated content. But yeah, this is really good. This is a really good foundation, if you want to know more about like how those tools work. And then this series is more so designed for, it is Google for startups, so it's designed for people who are either like running or operating a startup, or trying to build a startup. Like basically teaching different tooling. So it is like in the context of um, Google Cloud Platform, whatever services that they have available. They highlight those services and whatever tools that they pretty much built. So in this case, like everything that they're showing how to do is using like the tools that they have in their system. So I am enjoying it so far. But I did this material last year, was really, really good. It was really helpful for me. And then if you go through the Google for Startups programs, they usually have labs and things that are on this platform called Cloud Skills Boost. That's their training platform or whatever. And I would say, like, even though I do want to say this, even though right now I think if you you should do like Q1 before you try to do Q2 for startup school. Oh, I just I just disconnected myself, didn't I? I'm sure I did. Yeah. Oh, or is it just the site? Okay. No, that makes it okay. Yeah, yeah, yeah. It just started happening technical difficulties. I thought that was me. Um but it is available. Cloud Skills Boost. I want to talk about that real the site is cooked. That's cuz they literally were having a live session. The live session would have just ended right now. So, I was just watching it on. I always click out and go straight to YouTube to watch the session, but the session literally just ended like a few minutes ago, or it probably just ended right now. So it could just be like a bunch a bunch of people on the site at once, but it will come back up. So anywho, uh yeah, Cloud Skills Boost. I was just gonna say, regardless of when you sign up for any of the startup schools, they usually have labs and things that you can go through, and most of the time they give you credits for Cloud Skills Boost. So um you can, in Cloud Skills Boost, you can start, there's different paths. You can start all the way back at like some beginner paths as far as like technical content. So um how did I find out about it? I don't know. I think I just got a newsletter. I think I just got a newsletter from them randomly from Google Cloud last year. And I was like, "Ooh, generative AI program, like I want to go through that." But you know, I've been I've been in the industry for so long. I follow so many like newsletters and stuff. So it's really no telling. I I do like build different applications on Google Cloud, just depending on like the client I have and stuff like that. So I get emails from Google Cloud and Google Cloud Platform. So it probably was one of those, like a promotional email like that. But yeah, whenever we were doing this last year, when I found out about startup school originally, I did post that in the channel too. And then last year, when I was going through, most of the time, whenever the sessions were live, I just live streamed while I was like working on those. So yeah, usually if I do find different resources that I think would be helpful, I try to like at least post them for y'all. But if it's something I'm going to be using personally, a lot of times, you know, I try to live stream so y'all can see what I'm working on. So this is literally like, I think the content that they did last year was really really good. And I really like using Google Cloud Platform in general. I think like for machine learning, I do prefer them because they might not be like the flashiest, or you know, like AWS I think is like very popular. Like most people think about, oh, I should use AWS. um and then even for AI, like I don't think people think about Google first when it comes to AI. But the fact of the matter is, like, all of the advancements in the field right now all came from Google research. So I like to use their tooling because, you know, I know like the technical foundation is there. And Google is really good at building developer tooling. So even from the beginning, when I first got interested in AI, which was like probably 2017 ish, Google was like known for this project called TensorFlow, which is still around. But like when Google makes advances, like this is my perspective, when they make certain technical advances, they also like do a really good job of like translating those into like tooling that the typical developer can use. And I feel like they also make it relatively like the entry point as simple as they can. So when they were doing very complicated like machine learning and actually building models from the ground up, they were building libraries and frameworks that made it easy to create models. um so you didn't have to be a complete like research specialist in order to create models, but you could pretty much leverage like the best practices that Google was already seeing, as far as saying like, oh, hey, if you want to do a computer vision model that can do image recognition, then here is like, a library or a framework that you can go through, and it kind of has all the tools already outlined that you need. And that's the same thing they're doing with agents right now. So that's what I like. I feel like they always fill that gap between the developer and building the actual like tech. So, um, yeah, today was just this is week 1. So this was the second session. There's like, I think there's 3 weeks in this one. Let's see if I can get back to it. There's 3 weeks in this one. Cloud on air. Okay, it's still gonna be down. But yeah, there's 3 weeks in this session. I think it's 2 sessions per week, and then in the last week is 3 sessions. And then if you miss them, you can just watch the recording. And then back to Cloud Skills Boost. Whenever you do a startup school, these like AI startup schools, they always give us Cloud Skills Boost credits. So normally you would like subscribe to Cloud Skills Boost, but they give like free credits. So I have I didn't know they had this free tier. Ooh, okay. Yeah, in the past they didn't even have a free tier. So yeah, you need credits in order to like do the labs and stuff, but they give us like 200 for startup school or something like that. So you can find a path. It doesn't necessarily have to be like starting at the generative AI part, because they have other paths in here. And I just say that to say, because I know some people are new to programming and you're trying to like find tools to learn. So if you happen to get credits and like going through startup school, there's a lot of good paths in here. Like does the API developer path start with programming? I don't know. I think this probably you need to have some experience. Let me see. I know there's like a that's the beginner for generative AI. And there's definitely another one in here. They have beginner database engineer. I thought they had like a developer one. I'm not crazy. Cloud developer. Okay. So yeah, there's a few different paths that you can go. Um I need to get back to working on my I'm trying to work on the certification for Google Cloud, but anywho, that was a lot of information. The Black Founders Fund. I feel like I've heard of it, and I want to see. Yeah, because that's under Google. Um, well, this is the Black. Yeah, Black Founders Fund. Um, but no, I know there's some different like startup resources that I'm looking at personally, because I do have a like a startup idea that I'm working on. But either way, this is all like useful, because outside of me doing my own ideas, I work with a lot of startups. So like a lot of times I will have clients and I'm helping them build out their apps. And I want to be more like, I have to continue to just grow and offer new services and things like that too. So that being said, like a lot of new ideas that I've seen in the past sometimes that would have been hard to do programmatically, the whole like LLM like capabilities now opened up the door for a lot of things. So it's interesting in that way too, because like I have at least one specific project right now, probably two, but I have one specific project that's coming up that is going to be leveraging like large language models to do some like complicated document analysis and things like that. I'm not going to say exactly what the idea is, because that's a startup that I'm working with, but Yeah, I'm excited about that. I'm like, this also gives me like, it helps me work on some of the ideas that I want to work on, but it also gives me more service, like technical services to provide, and it opens up the door for like what types of solutions I can create, because like I said, like when the LLMs first got popular, it was like, oh, um we can like chat with them and they like are actually kind of competent in like responding and giving us information. It's like, okay, that's cool. But now, like I said, like the models can do video and voice and images and text. Like they can do all those interchangeably, and or natively, I really should say. And that makes a huge difference because when it was just a chat model, you still had to chain together all these other things. Like say if I wanted to say like build an app that can suggest like a extra no that can like recommend the shoes for me to wear based on my outfit. Then in the past I would have to have the chat model which can like possibly interact and have the conversation. Then I would have to have an image model, and the image model has to be able to like look at the picture and analyze the picture. Like I would have to do some type of like complicated integration between those systems in order to like do that. Now like literally I can work directly with the large language model and probably do that in one step and probably do it in one step, um or at least that portion of it can be like one component of the app by itself. I don't have to do like all those different model types. So anyways, I'm kind of going off on the tangent, but that is it's just making me excited because um the possibilities are like people aren't really seeing it quite yet. Like this is not like LLMs, like a chat the chatbot was like just the beginning. That's just one layer, but the LLM itself now, the capabilities of the LLM opens up the amount of like software and different applications that we can build. Like it's going to be a whole new wave of like products that's just built off of agentic systems by itself. So that's the kind of stuff that I be going down the rabbit hole on. Here, let me post it. Let me post the link. The Discord, if you're when you're on, oh, I don't know. Maybe if that one is active or not. Let's double check. But typically when you're on YouTube, you can just go to on the channel page. I always have a link in here. I'm about to double check if this is active though. Everything's so slow. But yeah, I'm gonna drop a link in here too. The opportunity, yeah, it's really a whole thing. It's a whole thing. Um, and it's very exciting for me. But I think it's gonna take people a minute to wrap their mind around. Um, Here I'm gonna put another link because I don't know why the YouTube one isn't responding. Hold on, I'll post it on YouTube. Yeah, it's gonna take a minute for people to wrap their minds around like, hey, this is how like this is just a piece of technology now. This is just a specific like core like aspect of programming of your application that you can use, like of your tool set that you can use, and then you can build around that. And that's pretty much that's what they showed in this session. Like back to this tab. I guess I messed myself up by going off of here, but like let me see. He basically wrote a program, and like again like the LLM is just a part of the program. It just does specific jobs. But you can give the LLM tools to use. So tools are like functions. I can have the LLM like be able to do certain specific tasks that it wouldn't normally be able to do. Like, hey, you can call this function to like go check the weather, for example. Like LLM is not going to necessarily be able to tell you the weather for the day. But if you give it a function that can call an API, then it actually can go and run that function, get the response back, and use that to like answer a question. So it's like building the tools, and then also there's a lot about like grounding. There's like a lot of things that have been done to allow the language model to have like access to like factual information. So for example, being able to, like, if you work at a company, then you can set it to where the model can go and look into like specific documents and answer based off information in specific documents. Then I'm just giving some examples, but it's like these are the different types of functionalities that has been enabled over like the last year or two. And then what else? I was gonna say something else, but yeah. Oh, and then the thing about Google, like I said, Google, they know how to take like they know how to take what they figured out on the tech side and then turn it into like a library or a SDK that makes it straightforward to go through the process. So instead of me having to like hard like actually code an agent, like I can just use the SDK that they have or some of the different tools that they have. Like I don't have to train my own model. I can use different models that they have available, for example, or I can interchange models. So they think about how to like abstract the different processes that they already do on the technical side and like make that available to developers. I think that's really what why I pretty much follow like my whole entire AI journey has been following whatever tooling that Google has, because that, like I said, it might not be the flashiest, it might not be known for being the best, but it's like literally none of what we're doing right now, none of what exists right now would exist if the research paper that they did is called attention is all you need, I think. um like attention is all you need. I know some of y'all haven't heard me go on this tangent before, but attention is all you need. This paper was um published in 2017. This is from Google. It's researchers from Google Brain and Google Research. So everything that we are like, all of the language models that are out right now, the popular like large language model, that whole thing came from this. OpenAI got most of the claim to fame in this process because they released ChatGPT, but all the research that they used for the model that powered ChatGPT, it came from this paper. Like they were using this research. So, that being said, nobody asked, but I care a lot. Yeah, retrieval augmented generation is definitely one of the ways of grounding, and I'm not trying to drop too many buzzwords on people, but yes. So right now in this case, like if you want to start building agents, like I would say if you want to use like the material that's in this like startup school, then before you jump in here, do the generative AI startup school, because like retrieval augmented generation, for example, they're not going to talk about that in this series, because that's like a foundational piece of information that you should already be familiar with. So it's going to be like where's the system that they showed? It'll be like, you'll see it in diagrams like this: LLMs, RAG, and you got your tools. But yeah, they're not going to talk about those topics in here. You need to go to the startup school from Q1, and that one talks about generative AI specifically, and that's where they would get into more of those tools. So that's the only thing. That's why I say if you want to do this training, I put the links. Both of the links are in the AI ML channel right now. Hold on, what time is it? Okay, I got 7 minutes. Oh yeah, here's the paper. Here's the paper. Attention is all you need. But me personally, I I always been into natural language processing specifically. I've done like some work before in the past where we were we were using TensorFlow and other tools that was out during that time to like try to build chatbots, and it, it was so hard to build something that sounded any form of competent. Like it requires so much compute power, so much programming, and we were still using like existing libraries and frameworks that was made available. But I wanted, where is the, hold on, where is the research Google blog? I'm gonna link the blog because the paper is super technical for sure. And I think the blog, they whole system is down. Something big is down right now. GCP. What's happening? Part of their system is down for sure. Wow. That's so funny. It's not funny, but it is because stuff like this be happening all the time. But if you don't program, you probably don't even notice. My mic is very low. My mic is as loud as it can be, y'all. I don't know what the audio is. And I tested it on my phone on YouTube too. If you can turn up the actual volume on a video, I don't know, cause I'm as loud as I can be without my mic peaking. But yeah, I think I posted. Yep, I posted Discord. Yeah, I got to be at a meeting in like 4 minutes. Could prompt the LLM to summarize the paper. Yeah, you can prompt the LLM to do way more than summarize the paper though. You can actually take a picture of the paper and then have it um uh actually give you a study a study guide for all of the different topics you should learn in order to in order to understand the paper probably. I want to know what this outage is though. Tom's guide. Nah, Tom is not helping. It's more than thousands. The Google Cloud is down for sure. But I wonder if it's bigger than that, cuz it's why would all the data centers go down? You All of the data centers on here in America are down. The Europe data centers, like it's literally every region. That's actually kind of scary. Not, I don't want to say scary. I shouldn't say that, but it is a little unnerving because what would make every single data center go down? Google Cloud is super, like this is a this is a global system. Like for every single data center to be like that, that's kind of we'll watch and see. This is the kind of stuff I miss having coworkers, because you just be sitting there like doing some work and then all of a sudden nobody can do work and it's like, oh, GitHub is down, oh, AWS is down, like, oh, GCP is down. But I do have to hop on a call. Hopefully um that's on Azure Systems, so we'll see. Hopefully that's not also going to be an issue, but it might actually, we might not be able to demo. Wow, we might not be able to demo because I think we are using Firebase. I don't know, we'll see. But I'll be back, y'all. I'll be back tomorrow probably. Cause I need to go through all the material. And here is the link once Google stuff comes back up. It would be accessible, but here's the link. I'll put it in the channel because that's the actual blog as well. So it talks about what the work was that they did, and then it also should link the research paper. And feel free to post. Check out the AIML channel in Discord. If you come into the Discord, introduce yourself. I will welcome everybody in. But I'll be back tomorrow because I need to study. I need to go through these videos like at length, and I also need to do all the labs from this week so I won't get behind. So I'll see y'all tomorrow, probably tomorrow morning. As long as I get my life together. Have a good afternoon. Bye.